Okay, good morning, Legend 8. Today we're doing probability of events. Okalani in the I'll continue to do the exercise and the lesson notes and send it and see you. Whatever you can do, you send it to me. Okay, now the probability is the seventh unit or strand. Then you have two more strands to go, and that's it. That's the end of Form 7 syllabus. So we are almost there. Please try and do whatever you can do and send it to me through inbox. Right now, we have probability of events. Probability is one strand that is nothing is removed from it. So you have to learn it well. The complement of event A, that's one event. Complement of event A is whatever that is outside set A. Okay, everything that is not in set A, that's the complement of A. So the probability of A, set A, its complement is outside. So this is the everything in the Venn diagram will always give you 1. If you add the probabilities in the Venn diagram 1, so PA plus PA complement will always give you 1. This and this, whatever is outside, and this will always give you 1. So remember that. Okay, the next one is called mutually exclusive event. Mutually exclusive event does not occur together. It does not have any common income. Does not have common intersection. Nothing is common between the two sets. That's called mutually exclusive. So when you are going to unite them, it's going to be probability A plus probability B. They have nothing in common. Okay, that's mutually exclusive. Independent events have something in common, but it does not affect each other. Okay, so that means A times the intersection is equal to probability A times probability B. That's for independent events. If A and B are disjoint, then this is called the additional rule. A union B is equal to probability A plus probability B minus probability A union B, intersection B. Okay, this is union, this is intersection. Okay, this is additional rule. This is used for disjoint function, disjoint events, and disjoint events are normally the independent events, not the mutually exclusive event. Okay, so we have an example here. The example is taken from one past year paper. Okay. Let A and B be independent events which probabilities A is equal to 0.4 and probability B is 0.5. Find A complement. Okay, so if we have to find A complement, A is 0.4. Okay, that means 0.4 plus PA dash will give you 1 according to this is a complement. So you go back to the formula and use the formula. Okay. And for this one, all you have to do is take these values, put it here, minus the intersection. The intersection, like in a formula, probability A times probability B. Okay, so go ahead and face it down so you can see how you work it out. Okay, this is for example 1. But A Example 1 part A, probability of A complement. According to the formula, plus probability A complement is equal to 1. We're given probability A, which is 0.4, plus probability A complement is equal to 1. So you're going to solve for this. Take 0.4 to the other side. Is equal to 1 minus 0.4. Your answer is 0.6. That's the probability of A complement. Okay, that's A. Right, good. So now I'll do B. B says probability of A union B, which is equal to probability of A plus probability of B minus probability of A intersection B. Okay. On this side, okay, I just quickly do probability of A intersection B. Then the formula is probability A times probability B. So what's probability A? 0.4 times B, 0.5. Okay, so if I multiply that calculator, 0.4 times 0.5 gives me 0.2. Okay, this answer here will go here. Okay, so 0.4 plus 0.5 minus this answer, 0.2. So do the addition first. It's 0.9 minus 0.2. So the answer is 0.7. Okay, so that's the answer for part B. Okay. If you see example 2, example 2 looks like this. That's example 2. Two feathers are rolled and the numbers of the uppermost faces are observed. The sample space is shown in the lattice diagram below. Okay, so that's a lattice diagram. If you roll two dice like in Form 6, you have to do a lattice diagram that looks like that. Okay, and let event A, the number on the first die is 5, event B, then the same, the sum of the numbers are more than 9. Okay, so if you go to the table, you can work out the probability of an event. Probability of an event is the number of events divided by the sample space. Right now you can see there are 36 sample space. The outcomes are all inside here. There are 36 outcomes. So that means everything will be over 36. Okay, so if you have to calculate the probability of event A, the first die is 5. So this is the first die, it's 5. Yeah.